Today's lesson is over spheres, and the goal is given a formula, I can calculate the volume of a sphere. So the actual definition of a sphere, okay, it's a set of all points in space that are given a given distance from a given point. Okay, you guys know a sphere as a ball. It's basically a three-dimensional circle. Basketball, soccer ball, the globe, any of those are examples of spheres. The Earth, planets, any of that. And the way to find the volume of a sphere is take 4/3 times pi times the radius cubed. Kind of a confusing formula, but it really is just a plug and a chug, and with a calculator, nothing we can't handle here. So let's try it out. Let's find the volume of the following two spheres. We'll do one at a time. So, like other formulas, I would go ahead and write out the formula from the get-go. So we can just go ahead and plug in values. So the volume is still the unknown. Okay, we don't know 4/3 is 4/3. Okay, pi, we know is going to be 3 14/100. And our radius is 11. Okay, 22 is diameter. So 11 cubed. So let's go ahead and do this all on a calculator, which is plug the numbers in and the answer will come back to you, which I'm doing right now, so bear with me. We have a large answer of 5,572 and 453 thousandths with a 3 repeating centimeters cubed. Okay, just plug and chug away. So now over here we have a sphere with a radius of 5. Again, kind of an awkward formula, so I'm just going to go ahead and make sure to keep writing this up. So we have 4/3 times 3 14/100. And 5 cubed, we know is 125, or we should know at this point. So we go ahead and multiply these together for an answer of 523 3/10 repeating millimeters cubed. Okay, that is it. Now, word problems. We have a spherical stone in the courtyard of the National Museum of Costa Rica with a diameter of about 8 feet. Find the volume of the spherical stone rounded to the nearest tenth. So we get our formula up here equals 4/3 pi r cubed. And since diameter is 8, it makes the radius 4. Okay, we should know that 4 cubed is 64. And at this point, it's just into the calculator and see what we get. 4/3 times 3 14/100 times 64 for a volume of 267 9/10 feet cubed, cubic feet. So we should go a little bit beyond just plugging and chugging. So we have a word problem like this. A volleyball has a diameter of 10 inches. A pump can inflate the ball at a rate of 325 cubic inches per minute. How long will it take to inflate the ball? Around the nearest tenth. So we've got this volleyball. I'm going to draw really bad spheres. Imagine that this is, three-dimensional. Okay, and we've got a diameter of 10 inches. I'm going to go ahead and make the radius just at 5. Get that out of the way for us. So we need to start by finding the volume of this volleyball. That's the first task we have to complete. And we had this problem before, the same numbers before. Right, if 5 is the radius, then 5 cubed is 125. I forgot the answer, so I'm going to go ahead and recalculate it. You guys can look up on your note sheet to find it from before. We got 523 and 3/10 repeating is the volume of our volleyball. Now, the pump can inflate the ball at a rate of 325 cubic inches per minute. How long will it take to inflate the volleyball? Round to the nearest tenth. Well, when I look at this as a ratio. A couple ways you guys can do this, but ratios, proportions help me see things better. So, in 1 minute, the pump can inflate 325 cubic inches. So the question is, how many minutes would it take to inflate a ball that is 523 and 3/10 cubic inches? So, cross multiply and divide. Okay, multiply these together. Same thing, 523 and 3/10 repeating. And then we divide that by 325 to give us our answer, which becomes, and it's the nearest tenth, so we have 1 6/10 minutes. That's the final answer, how long it would take to inflate the ball. So just take your time, write steps out, and you'll get the answer. Finally, we have a hemisphere, which is half of a sphere. So we find the volume of the hemisphere and round to the nearest tenth. So we're taking this whole thing. Basically, our formula would be 1/2 of 4/3 times pi times the radius cubed. So half of 4/3 is 2/3. So we have 2/3 times 3 1400ths times 5 cubed, which is 125. And give me a second here, we'll get a final answer. Answer here is 261 and 6/10 repeating centimeters cubed. This concludes your lesson over the volume of spheres.